Hey guys, I want to give you an example of how we can calculate the surface area of a pentagonal prism. So now we're looking at a prism where the shape of our base isn't going to be as easy as having maybe a rectangle or a triangle or even a circle if we were looking at a cylinder. So whenever we're calculating the surface area of a pentagonal prism or whichever type of polygon we're looking at, we need to make sure that we are calculating the area of the base and following the rules that we know. So to calculate our lateral surface area, we could use the formula capital P times H, which is the perimeter of my base. Now perimeter is looking at all the sides. Here would be my perimeter. This side plus this side plus this side plus this side. That is my perimeter. Okay. Now the height is going to be the distance between the two bases. So how far apart are the pentagons from one another? Okay, that would be my height. Okay, so let's keep looking at my formula and let's see how we can fill this in. So if I look at my pentagon, I'm only given this length from the center of my pentagon to one of the vertices on the pentagon. So what I'm going to do is I'm going to need to create a triangle here, and I'm going to have to do a lot more calculation in order to figure out this side right here, because once I figure out that side, then I can use that information to calculate the perimeter. The other thing that I forgot to mention here is we really need to understand that this is a regular polygon. That means all 5 of these sides are congruent. Okay? All right, so how can we figure out the perimeter? So I need to know what this side would be right here, this side on this triangle that I have. Now that I have this right triangle, so let me redraw the right triangle. Because I have a right triangle, I'm going to be able to, I'm going to be able to, you know what, that's not going to work as good. Let me just draw it. Because I have a right triangle, I can use trigonometry in order to calculate the length of the side. So here I have 12. This would be my apothem in terms of whenever we're going to have to find the area of the pentagon. So I'm looking for this side right here. So I need some more information. What I'm going to need to know is this angle right here. I need to know how big that angle would be. Well, since I have a pentagon, if I imagine this pentagon being divided into 5 triangles, okay? Each of these triangles, the top angle have to be such that I can do 360 degrees, since it would create that circle, divided by 5. So it's going to be congruent 72 degree angles right here. All of those would be 72. But if you notice, the triangle that I'm focusing on would be this blue right triangle, so I have to cut that in half. So 72 divided by 2 is going to get us 36 degrees. So this angle, now I know, is 36 degrees. So if I'm thinking about trigonometry and I'm thinking about SOHCAHTOA, I'm going to ask myself which of these trig functions would I use to solve for the side that I'm looking for right here. So it looks like from the perspective of my 36 degree angle, this is my opposite side, the 12 would be my hypotenuse. So that means I'm going to use sine. So then sine of 36 degrees is equal to my opposite, which is the side that I'm looking for. I'll label that as x, over my hypotenuse. Now to solve for that side, I'm going to have to figure out how I can get rid of that denominator of 12. So my denominator of 12 can be eliminated by multiplying by 12. So I'd multiply by 12 on both sides. So x is going to be 12 times sine of 36 degrees. So we can plug this into our calculator, and we're going to have to get a rounded answer. So 12 times sine of 36, I'm getting about 7.053. All right, that 7.053 is going to be just halfway, okay, halfway across, right? So if I want to go the full distance right here, if I want to know this entire distance right here, I'm going to have to double that. So if I double that, I'm going to multiply that by 2. So that means my side length here is actually going to be closer to 14.1. Let's just go ahead and round it to the 10th place, so we're not using too many numbers here. All right, so now, what was our goal? We wanted to find out what the perimeter was on my base, right? So my perimeter is going to be 14.1, since that's one side of the pentagon, times 5, since I have 5 sides on my pentagon. And then my h, remember that my h is going to be the height of my prism, how far apart the two bases are. So my height would be 15. So let me multiply these three numbers together. So I'm multiplying 14.1 times 5 times 15. And that's going to give me 1057.5. Okay, that is going to be a rounded answer, because remember we were using our trig, so we had to round whenever we found the length of the side. So it's about 1057.5 units squared. So that is going to be square units, since area is two-dimensional and we're solving for surface area. Okay, that was lateral surface area. Now let's go ahead and calculate the total surface area. So what I'll do is I'll calculate the total surface area in a different color. So total surface area. Total surface area is going to be my lateral surface area plus 2 times the area of the base. I already have my lateral surface area because we just calculated that. And now, to solve this, we need to figure out what we're going to use for the area of the base. So because we already have our triangle set up here, if you remember the formula for the area of a regular polygon, let me write that right here, area for a regular polygon is going to be 1/2 the apothem times the perimeter. Okay, so this is my apothem, the distance from the center of the polygon perpendicular to one of the sides. That means I need to solve for this side, because I already have the perimeter of my pentagon. So if I'm solving for this side, which is going to be my adjacent side in that right triangle, I would use the trig function cosine. So cosine of 36 degrees is equal to my apothem over the hypotenuse, 12. So to calculate my apothem, I'm going to multiply 12 times cosine of 36. Let me plug that into my calculator. So 12 times cosine 36 degrees is going to give us about 9.708. Let's round that to, I guess we can leave it as 9.7. So our apothem is 9.7. So area of my base, let me just erase this right here. Okay, that way I can write my area formula for a pentagon. 1/2 of the apothem, which is 9.7 times the perimeter. So what did we get as the perimeter? 14.1 times 5, which is 70.5. So I need to multiply that by 70.5. I'm running out of room. Let me scoot this over so we can see it a little bit better. Why won't it let me erase that? Okay. 1/2. 9.7 times 70.5. Plug that into my calculator. So 1/2 times 9.7 times 70.5. So the area of my base is going to be about 341.9. I'm going to round it. Lots of rounding here. Okay, so now to calculate, this is a little bit messy looking, so let me kind of just highlight what we're doing here. So we're trying to calculate the total surface area, so I'm doing the lateral surface area plus 2 times the area of the base. So let me go ahead and add that together in my calculator. So I have 1057.5 plus 2 times 341.9. So then my total surface area is going to be about, I'll write it up here, 1,741.3 square units. Surface area is two-dimensional. Okay, I hope that that was helpful, because now when you're calculating the surface area and the shape of the base is more unique and more intricate in terms of being able to calculate the area, there's a lot more steps that you really have to consider. So it's helpful to have out a piece of paper and to be able to write down the steps that you're using. All right, bye.